In the last video, we recognized that solving two-step equations was as simple as following this process. Assess the order of operations initially on the variable side. So we went over here, we said, okay, you would have had to multiply the 2 times the x before you could take away that quantity from the 7. So the first thing we'd have to do is multiply, the last thing is subtraction, and that's order of operations. So to solve, we said we undo, we go in reverse order of operations. We'll take care of the number that involved the subtraction first. We'll take away 7 from both sides. We got 8 was equal to, now this is key, 7 minus 7 is 0. 0 minus 2x is going to give us a negative 2x. That negative does not disappear. So this is equivalent to negative 2x is equal to 8. And our final step would be to say, okay, let's divide both sides by negative 2. We get that negative 4 is equal to x, and we solved our problem. But focus on the variable side, see what the initial order of operations was, and then to solve an equation, you undo those operations. You go in reverse order of operations. Keeping that in mind, it's like, ooh, that ugly, look at that. That's pretty weird looking, but upon further inspection we could say, you know what, that's just a bunch of constants that are being added together. How about before we go to this little roadmap, we just simplify this stuff on the right side. 17 plus 4 is 21, minus 2 is 19, plus 6 is 25. So it's like, oh, now we have this, hey, it's down to a regular two-step equation. So we could add a 0 step. Simplify before you jump into this procedure. So here we go. We look at that, we say, uh-oh, we have 2x terms on the left side. No problem. Let's simplify before we jump into this. We can combine the like terms. These guys right here, 4x plus 2x is 6x plus 3 is equal to 45. And now we go in reverse order of operations. We undo the weakest operation first by subtracting 3 from both sides, and then once we get 6x is equal to 42, we take care of the more sophisticated operation by dividing by 6. X is equal to 7. We're happy campers. Now we get here. Ooh, let's simplify, because all of this is one big glob and we can't get rid of that 1 from the 3x or whatever. So here's an approach. This is where we may like to use the distributive property. If we can distribute the negative 2 times this term and also times that term, we get rid of this ugly mess. Negative 2 times 3x is negative 6x. Negative 2 times, we could view that as a negative 1, like plus a negative 1. That's a positive 2. So we end up with this is equal to negative 28. And life is good. We just do the two-step process on that. But there's another way to do it. The nerd has spoken. He says, excuse me, you can actually do this a little bit simpler. So for the more advanced student, the student that can see numbers a little bit quicker and isn't scared to step outside the box a little bit and look for an easier way to do a problem, we could do this. As long as you do the same thing to both sides of an equation, you're fine mathematically. Because negative 2 is being multiplied by this quantity, and because negative 2 is a factor of negative 28, the first step, and really the easiest way to do this problem, would be to say, you know what, I'm going to divide both sides by a negative 2, because I can create a 1. Negative 2 divided by negative 2 is 1. 1 times this quantity is just going to leave you with that quantity. 3x minus 1 is equal to 14. Keeps the numbers a little smaller and you can jump to that. But either way, whether you distribute or you see cleverly that you can actually divide both sides by the negative 2, do a little simplification first and then solve the two-step process. Take care of the weaker operation. Let's add 1 to both sides. We'll end up with 3x is equal to 15. And then take care of the more sophisticated operation, the multiplication by 3. Undo that. We're left with x is equal to 5. That's pretty ugly. We got a variable on both sides. So again, we need to simplify. What you'd like is a variable term only on one side. So in comes the good math. As long as you do the same thing to both sides of an equation, you're doing things okay. You're doing good math. We'd like to create zeros and ones appropriately. We'd like to get totally rid of the 3x on the right side and somehow make it show up over here. But you can't just say, hey, come with us. We're going to come over here and you're going to join us. You can't do it that way. What you want to do is get rid of the 3x, make it go totally away. So if you subtract 3x, you get a 0, nothing left. So we're going to subtract 3x from this side also. Now the like terms are the 5x minus the 3x. That gives us 2x minus 2 is equal to the 0 plus 16. We know we correctly got rid of the 3x because there's nothing left. 0 plus 16 is still 16. And we have simplified and got it down to a two-step equation. I think by now we're okay solving that bad boy. Inequalities, pretty much the same as before. Simplify first, then do all these things, but keep an eye out for that situation where if you multiply or divide both sides by a negative, you end up having to switch the inequality sign. So let's do a similar thing that we did last time. Let's get rid of the 2x from the right side. We can do that by creating a 0. 2x minus 2x is 0. 0 plus 9 will just leave the 19 alone over here. We got to do the same thing to this side. Those are like terms. Negative 6x minus 2x is a negative 8x plus 3 is greater than this. Alright, well, the next thing we should do is take care of the weakest operation. Undo things. We got to take care of this addition before we mess with the multiplication. So we'll subtract 3 here to also get a 0. And we'll subtract 3 from this side. So we're left with 16. So cleaning this up a little bit, we have negative 8x is greater than 16. Final step, let's undo multiplication by dividing both sides by, a negative. So we need to switch the direction of the sign. Should actually happen right there, but it's okay to show it in the last step. So our final answer, x, switch from greater than to less than negative 2. So our answer is x is less than negative 2. That's only one way to handle this problem, and it might be argued that it's not even the best way. Let's look at a second approach and then we're done. We just did this. We just subtracted 2x from both sides, and this is what we ended up with. Sometimes what we like to do when we're solving an equation is to have a little foresight and to say, you know what, this is a bigger term. 2x is bigger than the negative 6x. So whichever side of the equation has the variable with the bigger coefficient, 2 is bigger than a negative 6, make that side the variable side. So get rid of a variable term from the other side. So how do we get rid of a negative 6x, make it totally go away? We create a 0. So add 6x to that, we get the 0, it's totally gone. 0 plus 3 is 3. Whatever we do on one side, we do to the other side. So what we're left with is 2x plus 6x is 8x plus 19. So now it's just a two-step equation. We have 8x plus 19. Let's work on getting x by itself. And so we subtract the 19 from both sides. We're going to get negative 16 is greater than 8x. At this point we say, hey, undo multiplication by 8. We divide by 8 on both sides. Now this time we don't switch the side because we're dividing by a positive, which some might argue that's the reason why we should get the bigger coefficient to be the side where we establish the variable. That'll be the variable side. But at any rate, negative 16 divided by 8 is negative 2 is greater than 1x or just x. So now these two answers are the same, aren't they? Because if negative 2 is greater than x, then x is less than negative 2. And that's the exact same answer we got here. So at any rate, just simplify before you do the usual appropriate solving of a two-step equation or inequality.